Electric cars, once a distant dream, are now zooming into the mainstream. As the world shifts gears toward cleaner energy, EVs are leading the charge. But what's beneath the hood of these silent speedsters? It's not just about plugging in and zooming off. There's a world of intricate technology powering these vehicles, from the batteries that fuel them to the motors that drive them. There's a lot to unpack. So buckle up. By the end of this video, you'll not only grasp how electric cars work, but also discover why they just might be the future of transportation. Let's electrify your knowledge. Did you know that electric cars aren't a modern invention? They actually cruised the streets back in the 19th century. Yes, before the roar of gasoline engines dominated the roads, silent electric vehicles were quite the rage. But as gasoline became more accessible and affordable, these electric wonders faded into the background. Fast forward to today, and they're making a grand comeback. Thanks to leaps in technology, especially in battery efficiency and power, electric cars are no longer just a nostalgic memory. They're at the forefront of a transportation revolution, promising a cleaner and more sustainable future. And guess what? This is just the beginning, diving right into the core of electric vehicles. Let's talk about the battery. Ever heard of the lithium-ion battery? It's the same technology that powers your smartphone. In electric cars, these batteries store energy from the grid and release it to power the vehicle. Their magic lies in their high energy density, allowing cars to travel longer distances on a single charge. Plus, they have a long life cycle, and good news for us, their costs have been dropping steadily. But it's not all sunshine and rainbows. Some folks worry about how far they can drive before needing a recharge, known as range anxiety. And while we're making strides in faster charging, it's still a hurdle. Not to mention the challenges in sourcing materials for these batteries. But the future looks bright with emerging tech like solid-state batteries, which promise even more efficiency and safety. Shifting gears from batteries, let's discuss the magic of electric motors. At their core, these motors transform electrical energy into the movement we see on the road. Unlike their gasoline-guzzling counterparts, electric motors are marvels of efficiency. Traditional combustion engines lose energy through heat and friction, but electric motors deliver power directly to the wheels, offering instant torque right when you press the pedal. And speaking of types, EVs mainly use three kinds: the powerful permanent magnet motors, the adaptable induction motors, and the efficient switched reluctance motors. But the real beauty? They come with fewer moving parts, meaning less wear and tear. Plus, they play a key role in regenerative braking, capturing energy that would otherwise be lost. Imagine you're coasting down a hill in your car, and as you press the brake, instead of just wasting that energy to slow down, your car cleverly captures some of it to recharge your battery. That's the magic of regenerative braking. Unlike traditional braking systems where the kinetic energy of the moving car is lost as heat, regenerative braking converts this energy back into electricity. This electricity is then stored in the car's battery for later use. It's like giving your car a mini energy boost every time you brake. The perks? Your electric car becomes even more efficient. You'll find yourself needing to replace the brake pads less often, and you might just squeeze out a few extra miles from your battery. It's a win-win for both the car and the environment. Diving deeper into the electric car's anatomy, let's talk about its brain, the power electronics. Imagine you're at a busy intersection, directing traffic. That's essentially what inverters and converters do. They're like traffic cops, ensuring electricity flows smoothly from the battery to the motor and other parts. The inverter shakes the battery's direct current, or DC, and changes it into alternating current, or AC, for the motor. On the other hand, the converter does the opposite, ensuring other car components get the right type of power. And just like how smooth traffic ensures a city runs efficiently, these components are crucial for the car's performance. If they hiccup, the car might not run as efficiently or even at all. Lastly, let's plug into the world of charging. Imagine refueling your car, but instead of gas, you're using electricity. There are three main types. Level 1, which is like sipping through a straw from a regular home outlet. Level 2, a bit zippier, often found in public places and homes with special equipment. And then there's the DC fast charging, the speed demon that juices up your car in a jiffy. While many enjoy the convenience of charging at home, public stations are sprouting up everywhere for on-the-go top-ups. And the future? It's electrifying. Think wireless charging pads, chargers as fast as a coffee break, and even swapping out your battery like you'd change a watch battery. The future of refueling is undeniably electric. And there you have it. If you're as charged up about electric cars as we are, keep exploring and stay connected. Remember, every revolution starts with a spark. Until next time, drive safe and stay green.